Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Today's focus is on a crucial insight that often gets overlooked: data. Yes, data is more important than algorithm complexity. In machine learning, there's a tendency to chase the latest or most advanced algorithm. But here's the truth: even the most sophisticated algorithm will fail if it's trained on poor quality data. Conversely, a simple algorithm can perform exceptionally well when powered by clean, abundant, and relevant data. Why data matters more? Yes, dear friends, algorithm can only learn what the data teaches. See, machine learning models are fundamentally dependent on the data you provide. If your data is noisy, biased, or incomplete, the model will inherit these flawless regardless of its complexity. Better data beats a better algorithm. See, studies have shown that improving data quality or increasing the size of your training dataset often has a greater impact on the performance than fine-tuning your algorithm. Next, domain-specific knowledge comes through data. For an example, in medical imaging, a data set with diverse, accurately labeled X-rays is far more valuable than trying to apply cutting-edge algorithm to a small, biased data set. I just give you a real-world example. Google Translate. Yes, dear friends, Google Translate didn't achieve before its success just because of innovative algorithms. Its performance improved dramatically when Google gained access to massive dataset of translated text across different languages. These datasets provided the foundation for accurate predictions and translations. Similarly, in image recognition, a simple algorithm trained on millions of high-quality labeled images can outperform a complex neural network trained on a limited data set. I just give you a practical steps to focus on data. The first of all, data quality over quantity. See, while having a large data set helps, quality matters more. Ensure your data is clean, well labeled, and relevant to the problem at hand. Next, diversify your data. Yes, dear friends, include diverse examples that represents real world condition. For instance, if you're building a face recognition system, ensure your dataset includes people of different ages, ethnicities, and lighting conditions. Next, iterate on data collection. It's very important. Don't stop after gathering an initial dataset. Review your model's error and add examples to address weaknesses. This iterative process improves both data and model performance. I just give you a best case study: autonomous vehicle. One of the biggest challenge in autonomous driving is gathering diverse driving data. See, companies like Tesla and Waymo continuously collect data from vehicles in various weather conditions, traffic scenarios, and geographies. So this emphasis on data collections ensures their model can generalize well to new unseen situations. And here today's takeaway: yes, the next time you are troubleshooting a model, ask yourself, do I need a better algorithm or does my data need improvement? Often the answer lies in refining your dataset. Remember, data is the fuel that powers machine learning. So if you found this helpful, don't forget to like, subscribe, and share it with anyone else who would enjoy learning about AI and machine learning. And if you got any questions, doubts, or topics you would like me to cover next, drop them in the comment box. I will be happy to dive deeper in upcoming videos. Thanks for watching, and see you in next video. Happy learning.